Hello and welcome to Grey Matter. In today's video, we'll be discussing reinforced concrete, one of the most important materials in modern society. It's the reason that we're able to live in cities, the reason that you're able to go and see your favourite sports team play. It literally acts as the foundation for modern society. And incredibly, it's fulfilled this role for over 8,500 years. In 6,500 BC, in the modern-day UAE, early structures incorporated rudimentary versions of concrete into their floors, walls, and underground structures. In 3000 BC, the Egyptians were using mud with a straw aggregate, an early version of cement, as well as 500,000 tons of mortar in the pyramids. Nearly 2,500 years later, the Roman Empire started using concrete in a widespread method. Over the next 400 years, concrete was incorporated into all of their construction. This construction included large buildings and seawalls, both of which had never really been done before. The effectiveness of this can be seen as the structures are still here today, baffling many scientists on how they achieved such high strengths. Amazingly, most of this knowledge was lost after the fall of the Roman Empire in 476 AD, and it wasn't until 1414 when the manuscripts that detailed the formulas were rediscovered. 1793 was the rebirth of modern concrete, improving over time until we have the product we know today. It's interesting to note that every single use of concrete throughout history was using compressive strength. But what does that mean? There are two types of forces. The first one is compressive. You can think about this as a squashing force, or you can imagine a beam with two forces either side trying to push together. The second kind of force is a tensile force. You can think about this as a stretching force, or imagine two forces at the end of the beam trying to move away from each other, taking the beam with it. Beams and structures have loads, maybe cars driving across them, which results in an overall force. We normally express this force as a series of smaller forces acting across the entire beam. Now these smaller forces can cause bending in the beam. This bending creates an area of compression and an area of tension. The area of compression is because the length on the top of the beam becomes slightly smaller, pushing the concrete in tighter together, and the length on the bottom of the beam slightly longer, meaning that the particles are being ripped apart. A good example of this is shown here, where you can clearly see on the bottom there's cracks where the concrete has been pulled apart, and on the top you can see slight crushing where the concrete has been pushed together. Concrete's ability to withstand these compressive and tensile forces are called its compressive and tensile strength. Basically, how much of these forces can the material withstand? In the case of concrete, its compressive strength is much stronger than the tensile strength, about 10 times larger in fact. Because these forces create a compressive and tensile zone, there's a stronger and a weaker side of the beam, which is a problem because the weaker side can start to crack, leading to serviceability issues, if not total failure of the beam. So how do we fix this? Simple, we reinforce it with steel. If we look at the properties of steel like we did with concrete, we see that steel has a much higher tensile strength than concrete. So if we look at our concrete beam again, we simply add in a steel bar in the area undergoing tension. So now we don't need to rely on the strength of the concrete. This method also gives us some flexibility in design, as if we decide we need additional tensile strength, we simply add additional steel. Now, although in this video we've only discussed beams, the exact same principle can be applied to any structural element, whether it's a slab or a column, regardless of its shape or orientation. Simply, the important thing to remember is that concrete has a high compression strength but a low tensile, So we substitute in another material with a higher tensile strength to make an overall stronger element. Thanks for watching. Now, considering that grey matter is in its infancy, I'd really appreciate some advice and feedback about what you did and did not enjoy about the video. Please like and subscribe, and if you want to see any topics in particular, please leave them in the comments. Although I do have a fair few ideas for future videos, I'd really like to create content that you guys actually want to see. So if you have any ideas, please let me know.